Okay, so probability so far. We want to talk about theoretical, and that's pretty much everything we've been doing has been theoretical probability. We haven't actually done any experiments. We haven't actually had you rolling dice or flipping coins. That's how you do experimental. Theoretical is what's supposed to happen. Experimental is what actually happened. All right. Theoretically, what's the probability of rolling a 7? There are 36 things that can happen when you roll 2 dice. You can get a 1 and a 6, a 6 and a 1, etc. There's 36 outcomes, they're called. And what I want to know is what's the probability of getting a 7? Yes, sir? 6 out of 36. I agree. There's 6 things that you want to happen that will give you a 7. What are those 6 things? Would you tell me what they are? Yeah. 3 and a 4. 4 and a 3. Why does that count different? Because there's 2 different dice. This one getting a 4 and this one getting a 3 is different. They will both add to 7, but they're different combos, okay? And then 1 and 6, I was going to do the 2s. Okay, 2 and 5 and 5 and 2, 1 and 6, 6 and 1. Good. So there are 6 things. There's your probability of getting a 7. Raise your hand if you got that one right. Okay, good. The next one. What's the probability of rolling an 11? Much smaller probability. Don't say it, write it. I want you to compare with the person that I pair you with. We're going to go, let me think, there's 4 here, 5 there, so we're going to go you 2, you 2, you 2, you 2. You are going to pair with him. You're going to have to do double duty. You're social enough, you can handle that. Okay, and then it's these 2 rows, got to go kind of diagonal. You 2, you 2, you 2, you 2. And then these 2 rows match up just about perfectly, except you have nobody. So could you compare diagonally with her too? Thank you. All right, tell them what you think. Your probability of 11. How many ways to get an 11? How many things could totally happen? Therefore, it's 2 out of 36. And on the 2 ways to get an 11, some of you just still don't get that you got to be able to reverse them. It's a 6 and a 5, or a 5 and a 6, and that counts as 2 things because there's 2 dice. Okay, so 2 out of 36. What's the probability of getting a 7 or an 11? Like if you win in the game of craps in Las Vegas, if you roll the dice at the beginning, it's the one you've probably seen in movies. There's a big green area where you roll the dice on. It's a big kind of like oblong table, and there's a bunch of numbers out there you can bet on. There's also just called the pass line. And if you put money behind the line, you're betting that the guy that's rolling the dice is going to either roll a 7 or an 11 on his first roll. If he doesn't roll a 7 or an 11, then it just sets a number. So let's say he rolls a 5 instead of a 7 or an 11. If he rolls a 5, then every time he rolls a 5 again after that, you win. But as soon as he rolls a 7 or an 11, if it's not on his first roll, when he rolls it like a second or his third or his fourth roll, then the house takes every bet on the table. Now, there is a lot of people who play craps, and because actually, if you play it right, it's the game you can get closest to even odds on. The closest thing to even odds in Las Vegas is in craps. But there's a lot of really crappy bets you can make. So there's only one bet on the table that is this certain bet, which doesn't give you an advantage. All it does is it's the only thing in Las Vegas that is actually even chance. Like fair payout for how much you put on the table. Kind of like if you played this game, flip a coin, you know it's a 50-50 chance, right? And if you paid $1 and every time you win you get $2 back, that would be a true fair payout. That's the only thing in Las Vegas that's fair. All right, so I'm talking about the 7s and 11s because, again, on your first roll, if you get a 7 or an 11, then you win. All right? So when I say or, do you get that I want to take this plus this? When you do or, you add them. So do you get 8 out of 36 then? All right, so there's only an 8 in 36 chance. Let's reduce that. 8 and 36. 2 goes into both of those. So that'd be the same as 4 over 18. And then that reduces again to 2 over, only a 2 in 9 chance of it happening. But if it does, then you win. So theoretically, I should have to roll these dice how many times to be pretty confident I get one of winner? 9. If I roll it 9 times, it should come up once. That's what that means. Once. 2 out of 9. Sorry, my bad. Out of 9 times, you should win twice. So I get you. You were right when you said 4. I did a different example last hour. I apologize. Okay, so if I win on the first time, that'd be pretty cool. All right, so, all right. Ready?
Wait, we should bet. Wait.
I
got money. What are we going to bet?
What are we going to bet? Okay, how about if I win, you have to sing a solo?
Oh, yeah.
It's only a 1 in 10, 1 in 10 chance. And if you win, if I don't win, I have to sing a solo. I could wear pink pants. I don't have a pink suit. I could wear a pink shirt and pink pants. How about that?
Sure.
I don't have a suit. I'm not buying a suit for this. All right, Jack, you ready?
Wait.
Okay.
And this is if I get a 7 or an 11.
Yep. 7 or 11. Now, just to clarify, I'm the one who's rolling, so if I get a 7 or an 11, I win.
Yeah.
All right. And therefore, you have to sing the solo.
Wait.
If I get a 7 or 11, if you get anything else besides a 7 or 11, you win. I'm rolling.
I have the better odds.
You do. You do. There's a chance I'm wearing pink here. All right. Here we go.
I have to sing a solo, too. 7.
Woohoo! All right. All right. I know it's hard. Double or nothing. All right. So that means if now
You both have to sing a duet.
I think you have to sing a solo. Let's see. While
I'm punching him.
while Noah's punching him. No, I don't think we can do that one.
Tap dancing in front of the classroom.
While tap dancing. All right.
And then you have to wear a pink suit 2 days in a row. No, what do you...
I already won the first one. I just have to wear the pink suit.
No,
I'm already ahead.
He's doing you a favor.
All right, here we go. 7 or 11. Come on now. Woo! All right. So now,
I have a question. I'll just wait.
are these weighted? Oh, that is a good question. I don't have tap shoes with me. All right. So one more time, just for fun. What did it come up this time?
11.
11. Holy cow.
Good job.
School is
All right.
This is amazing.
School is dumb.
Weighted?
I would like you to inspect the dice.
That just rolled a 7 again?
What are the odds of that?
5 weighted dice. I hate you.
You bet it.
Totally are.
All right. So the dice. Anyway, so you should. I retract the bet. You don't have to pay off because I was cheating. All right.
no other way.
So yes, they are. They are cheat dice. Now I'm going to pause for a moment while we settle the mayhem. So we determined that those cheat dice that I had one die had only 5s on it, and the other die had 2s or 6s on it. That meant you were always going to get a 5 plus a 2 or a 5 plus a 6, which means 7 or 11. And they're very effective. You've only seen normal dice. I bet you've never seen dice that are cheat dice like that before. So you're so used to dice that you just expect them to be fair. Okay, so that's one of the reasons you got to watch out for that if there's a con man, because they play on those things you're used to. All right. No, he doesn't have to pay off. That's too cruel. I know you'd like to see that, but It's his fault for not catching it, huh? All right. Now let's do independent versus dependent. Typical test question for tomorrow. Get focused on the test. We do have a real test. It counts in the 85. If you're not going to be here tomorrow, then you will take the test on Friday. But you hopefully will have a chance to get smarter between now and then, because if you just put it off by a day, that doesn't make you get any smarter. So make sure you're ready for it. Okay, independent versus dependent. If you roll a die, I'll give you this hint. Dice questions are always independent. Coin questions are always independent because you can't like make the coin remember what happened the time before. But if you do card questions, they can be either. Let's talk about that. Independent means that it's the same this time as it was the time before, and they don't have any memory of each other. Pick a card, any card. What's the probability he's going to pick a club? 1 and 4. 1 and 4. Or, how many clubs are there in the deck? What'd you get?
13.
You got a spade, so it's not a club. Okay, the likelihood of that was pretty high. In fact, that's one of your questions. Would you please answer for me? What's the probability of drawing a club? Just to clarify, there are 13 clubs in the deck. This is something that, like, a lot of kids don't know. It's called a culturally biased question. So we will provide this for you on the day of the test. This slide right here is allowed to be on the screen. Why? Because some kids don't have card experience. In fact, some kids aren't even allowed to play cards as a part of their, like, cultural beliefs. So anyway, there is, I don't want to talk about that, but there are some. So anyway, those are the diamonds. What I said is the probability of getting a club. There are 13 of each kind. So there's 13 clubs out of a total of 52 cards. You should have said 13 out of 52. Raise your hand if you had that one right. Okay, good. What's the probability then, if we follow that up, that you pick 2 clubs? And is that going to be independent or dependent? Well, it says you do not replace the first card before picking the second card. Is it dependent or independent? Dependent, because it depends on what card you get first then. All right, probability you're going to pick 2 cards and get a club. Figure it out. I'll give you a hint, 2 fractions. And you always multiply probabilities. Well, the first one's simple. The first one, but we're assuming he gets 2 clubs. So we know what the first card's got to be. So it's 13 out of 52 for the first club. We all knew that before. So, or 1 and 4, correct. But it's better to use 13 out of 52 only because now our number of cards changes only by 1. And our number of clubs changes by 1. Tell me what fraction I should write. You got it. Do you get how that worked? Because now there's less clubs because we got 1 the first time. How do we know we got 1 the first time? Because that's what we're doing. We're saying we got 1 the first time. So 13 out of 52 times 12 out of 51. And that comes out to 0.059. So there's only a 6% chance of that happening. Another way to say that, there's a 94% chance it will not happen. Pretty high chance it will not happen. Try it though. Get 2 cards at the same time because it's the same as picking them one at a time. So there's 1 card, and he's got a spade. Too late. He lost already. But remember, there was a 94% chance. I know, but technically, if you pick 2 cards at the same exact moment, it's the same question as if I picked them one and then the next. It is. The only thing is that if you look at the first card, then you'll know information that you wouldn't have known if you'd drawn them at the same time. But either way, it's the probability still. I picked 2. Ooh, I got 1 club. In fact, you could do that. What's the probability you pick 2 cards and one of them is a club? Why don't you do that one next? You pick 2 cards, one of them is a club. First card is much easier than the second card. On the first card, there's a 13 and 52 chance you're going to get a club, right? The second card depends on what happened on the first card. We don't know if we got a club on that first card. So if you already got a club, well, then you already have one, so to speak. We only needed to get one club. So you would need to make a great big tree diagram to solve that problem. So let's not take the time to do that one. It would take forever. You'd have to look through and find all the possible combos you could get with 2 draws of 52 cards. That would actually be 52 times 52 combinations. There'd be like 50 times 50 is 5 times 25, add 2 zeros, 2,500 possible combinations.
How long will this test take?
I'm rounding here, but okay, the test will be a normal size test. Oh, it'll take you the normal amount of time. In fact, I think you'll have a little time left over at the end. There's only like 17 questions or something. All right. So this next question I actually want you to do is much easier. Find the probability you pick a red card, then a king of clubs. That's 2 fractions being multiplied. Now, red card. I know some of you are thinking that that's 13 out of 52. Red card is actually 2 of the kinds. So there's 2 sets of 13, sorry. So it's either this or this. Notice me adding them on top out of 52. And yes, you could have just said 26 out of 52 for that first one. Okay? The reason I did 2 is because it was the diamonds or the hearts. They're both red. And the or means add, and I'm just trying to remind you about or means add. Okay, next thing. King of clubs. Do you get that there's only 1 in the whole deck? 1, I shouldn't put a K, I should put a 1. 1 king of clubs. And the probability it's out of how many cards are left in the deck? You always got to rethink that. 51 cards, because we only took 1 card before, right? Yes, sir.
So is this
Good question. And the problems that we are doing right now, just do the multiplying of the fractions in that order. In other words, this would be first and this would be second, but actually, if you think about it, multiplication, unless you're talking matrices, the order wouldn't matter. But it would matter if you picked the king of clubs first, then your probability of a red card would change, wouldn't it? So actually, the order does matter. My bad. The order does matter. Because if you do get the king of clubs, now there's a higher chance you're going to get a red card because there's less black cards in the deck. So his question was, what if we reversed it? You're not going to have to do that. But if you did reverse it, if you got the king of clubs first, then your probability of a red card would be more than 13 out of 52. I don't think it's the same thing. It's close, but it's not the same thing. If you rearrange the question, then it would be like this. The king of clubs is 1 out of 52 times. Then the other one would be there's still 26 red cards, and you know what? You might be right. Hold on just a second. Let me see if that ends up working out to be the same thing. 26. Yes, it is the same thing. Thank you for clarifying that. Very good. Nice job. I was assuming it's different, but yet it's the same. When you multiply it all out, it will be the same. They're different fractions, but the answer is still going to be the same. You're right. Okay. When order really matters is in the next unit, and it's going to make it more complicated, but one step at a time. We don't have to worry about order yet. Okay, let's go down to Weatherman Jeff determines the chance of snow is 24% for tomorrow and 35% for the next day. For this, you are going to want to have a, a tree diagram. Would everybody please make the tree diagram for snow and no snow? I would just say use S and N. S means snow, N means no snow. And for tomorrow, it's 0.24, and then if it's 0.24 chance of snow, what's the no snow chance? 0.76, very good. Chance of no snow. And then the next day is here. Snow, no snow. Finish that chart out. I'll pause for a second while you do that. All right, here we go. On the snow versus no snow, hey, some of you aren't listening this way. The snow versus no snow on the second day, it should have been 24. Nope, it shouldn't have been. It changed on the second day. It says right there, 35. So it's 35 and 65. If you didn't notice that, your chart's all wrong. Okay, now let's do the probability of 2 days of snow. Well, it's really pretty simple. If it's going to be snow and then snow, it's this one and this one. We wouldn't have needed a whole chart for that. Okay, so then that's 2 days of snow. The other ones would not, none of the other ones would have 2 days of snow. So 0.24 times 0.35 gives you your answer. That's not the one I'm worried about. That one was an easy one. The next one, you may not know how to read this properly, so I'm going to explain it. This little bar means given. And your given is, I made a mistake on this in my first hour. You wouldn't, but I don't think it'll matter on the test because we're going to say it in words on the test. We'll say given. Okay? Or something like given. Given that there's at least 1 day of snow, what's the probability that it snows on the first day? Okay. Now, given there's at least 1 day of snow, that changes my denominators. Givens change the denominator. So all the things that were possible change based on that. Does this one have at least 1 day of snow? Then that's one of the possibles. Does this one have at least 1 day of snow? Yes. So that one goes into the possibles. Does this one have at least 1 day of snow? Yes, because there's snow here and no snow there. And, yeah, it has 1 day of snow. That's the question. Look at least 1 day of snow. I'm talking about this. When you do the possibles, you would only look at the given. Okay? And so these three together get added up, and those go on the bottom. Why didn't I include this spot down here? Because it wasn't possible. Because we said there's going to be at least 1 day of snow, and this doesn't have 1 day of snow. Okay. So those three, if you made a good chart here, those three got added together and go on the bottom. The one we want is it snows the first day, okay, which is this one or this one. Both of those had snow on the first day. So we need to add up the top two and put them on the top. This is what we want. The top two, this one and this one. And they go on top. And what was on the bottom is all three. This one, and this one. Final answer, 100% probability. Now, okay. Oh, I get it. I read it backwards again. I really don't like this symbol because it confuses me. You're right. The way I explained it was backwards. I apologize. Okay. I need to do a different one like this. So what I'm going to do is give you a chart that's got all the probabilities on it. 0.5 for this one, 0.01, 0.09, 0.30, 0.05, and 0.05. Here's my chart. Use this chart now. Okay, what I want you to do, focus please, thank you. What I want you to do is figure out the probability here, if this is going to be red, white, and blue, and then this is going to be, what are other common, let's go yes or no, yes or no, yes, no. First, let's do a simple one. What's the probability of getting white and no? 30% chance. Given that the color was gonna for sure be red, because you rigged it ahead of time, you knew it was gonna be red, then what's the probability the answer was going to be yes? Nope. Nope. Given that you knew it was going to be red, do you get that that means Only these two things are possible now. And they go on the bottom then. So what goes on the bottom? 0.5 plus the 0.01 is 0.51. And the yes was the 0.5. It's 0.5 over 0.51. All right. Your assignment is the review on probability. Also check your answers. The quiz is tomorrow. And I'm making the call right now. If you decide that you want to have an extra day to review, you can have it, and you can take the test on Friday if you would rather. It's just a choice. Some people will want to take it tomorrow. All right, so bottom line, feel free to take the test tomorrow or Friday. Either one's fine with me. Whenever you feel ready. That's all I got for you. Have a good day.